I welcome all the teachers and students to Unit 2, Session 5 of Thermal Engineering and Engine Testing, third semester Automobile Engineering branch. The unit name is Thermodynamic Process. In this session, we are going to learn about thermodynamic process, and then we are going to learn about different methods of simulating thermodynamic process, and then we are going to learn about simulation of constant value process using different simulation methods. Then simulation of constant pressure process with the help of different simulation process, different simulation methods. And then we are going to refresh ourselves with the help of a multiple choice question session. In this slide, we are going to learn about the meaning of thermodynamic process. Thermodynamic process means if a system's properties change because of any external stimulation like addition of heat or removal of heat, then we say that that system has undergone a process. It simply means that if a system's properties change because of any external stimulation, then we say that that system has undergone a process. In this slide, we are going to learn about different types of thermodynamic process. The first one is reversible process. In this, the name itself suggests it is reversible process. It means when you add heat, certain quantity of heat to a system, the system's properties change to new values. If you somehow if you bring back the final values of the properties back to the initial values, then if you can recover uh, whatever energy that you have given to change the values completely, then that is called as reversible process, which is not possible as per second law of thermodynamics, because um, there is efficiency involved. There will be always some sort of a loss in any energy transfer process or energy conversion process. Then irreversible process. These are natural process wherein you cannot recover the energy that you have given to the system to change the values of its properties. When you can somehow regain those values back to the initial values, that is what is called as irreversible process. Then there is flow process. This flow process is related to open systems, wherein both the substance of the system as well as the energy can cross uh, the boundary or can be exchanged between surrounding and system. Then there is non-flow process, which is related to closed systems, wherein you can only exchange the energy between surrounding and system, not the mass, not the substance of the system. Then there is a constant volume process, wherein the volume of the system is kept constant during this process, which is called as isochoric process. Then there is constant pressure process. In this process, the pressure of the system is kept constant, and other two variables like volume and temperature are varied, and this is called as isobaric process. Then there is constant temperature process. In this process, the temperature of the system is kept constant, and other two values like volume and pressure are varied, and it is also called as isothermal process. Then there is isentropic process, wherein the entropy of the system doesn't change, and other things like pressure, volume, and temperature, they change. Then there is last one, that is polytropic process. Then in this slide, we are going to learn about different methods of simulation of a thermodynamic process. The first and very easy method is using the online simulations available. One of them is this physicsmonster.org website. There are many websites available. This is one of them and easiest. Then you can create your own simulations using Microsoft Excel application. Then you can install Python programming language and its development environment onto your computer, and then you can create your own simulations using this Python programming language. So that is one more method. This link shows how to install Python programming environment onto your computer and then run a simple program. And this this link shows a YouTube video which shows how to install matplotlib library in Python programming language environment. This matplotlib library is very much needed to plot graphs like PV diagrams, TS diagrams. And then this slide shows different Google Drive links and different links. The first link shows the online simulations available at physicsmonster.org. If you click this link, you will be directly taken to physicsmonster.org website, and you can use those simulations to simulate the isochoric process, isochoric process, isothermal process, and then isentropic process. Then there is this link will take you to my Google Drive, where I have uploaded the Excel worksheet which contains the simulations of isochoric process, isobaric process, isothermal process, and then isentropic process. And then this link takes you to once again to the Google Drive, where I have uploaded my programs. Those are created in Python, using Python. I have only uploaded the isobaric process. You can use the same program. You can open that program into the Python development environment, and you can modify the code to create your own isochoric simulation. This link once again shows you, takes you to YouTube website, where you can find the video on how to install Python packages and then how to run a program. This link takes you to a YouTube video, which shows how to install matplotlib library to run a Python program to plot a graph in Python programming environment. Okay, now let us directly go to multiple choice question session. Welcome to the multiple choice questions session. Here in this case, we'll refresh whatever you have learned in this session. The first question is, the isochoric process is also called as. The answers are constant pressure process, constant volume process, constant temperature process, constant entropy process. As we know, the isochoric process is called as constant volume process. Hence, the answer is B. The answer is B, constant volume process. Let us move to the next question. The governing equation for isochoric process. It means the equation for isochoric process. Let's see the answers. This is the first answer, that is P1 by T1 equal to P2 by T2. The second answer is V1 by T1 equal to V2 by T2. Third answer is P1 V1 equal to P2 V2. Fourth answer is P1 V1 raised to gamma equal to P2 V2 raised to gamma. See, the last one, D, is for isentropic process. C is for isothermal process. B is for isobaric process, because here there is no pressure P. Hence the answer is the first A, because here there is no V, because V is constant. Therefore the answer is A, that is P1 by T1 equal to P2 by T2. Let's go to next question. The work done during isobaric process. Okay, we have to choose the equation for isobaric process here. This is the first equation, which is MR is in the bracket T2 minus T1, and then P2 V2 minus P1 V1 divided by gamma minus 1 is the second answer. Third answer is 2.3 P1 V1 log V2 by V1. Fourth answer is P1 V1 minus P2 V2 divided by gamma minus 1. So this is for isentropic compression, and this is for isothermal process, and this is for isentropic expansion. Therefore, this is the answer. A is the answer. That is MR T2 minus T1. Let's see. Yeah, that's right. Then let's go to next question. The work done during asymptotic process. What is the formula? You have to choose the formula um, for finding work done during asymptotic process. The first answer is A, P into V2 minus V1. Second answer is 0. Third answer is 2.3 P1 V1 log V2 by V1. And the fourth answer is P1 V1 minus P2 V2 divided by gamma minus 1. This P into V2 minus V1 is for isobaric process, 0 is for isochoric process, 2.3 P1 V1 log V2 by V1 is for isothermal process. Therefore, the answer is P1 V1 minus P2 V2 divided by gamma minus 1 is the answer. Hence, the answer is D. That's right. Thank you. Thank you very much.